Hello, Mr. Dodd back again. I'm going to talk briefly about even, odd, or neither functions. Um, Functions being even, odd, or neither end up working just like symmetry. So a good place to start thinking is that even exponents are going to help you be even, odd exponents are going to help the function be odd, and then even uses the same test as y-axis symmetry, and odd uses the same test as origin symmetry. One thing that I want to point out is that they must be functions. So I'm actually going to use the same graphs I used earlier and just work through real quickly. But this guy I told you earlier is a circle with a radius of 2. So this function looks something like that. But in order for something to be a function, you have to pass the vertical line test. And this one fails the vertical line test. So it's not even a function, so we can't even discuss it as even or odd. Next one, same thing here. This guy's going to be like this. It does have x-axis symmetry, but that's not a function. I failed the vertical line test, so we don't need to worry about that one. The third one, however, see how I have this x squared right here? If I plug in negative x, so I'd get y equals negative x, quantity squared minus 2. Y equals x squared minus 2, that matches the original, which tells me that this function is even. If I focus on the x's here, this would be x squared, which is a 2, and x to the 0, which is how we write it if it's just a constant. Both of those are even numbers, so that is why I have an even, which is the hint I gave you at the very beginning. All right, next one. This is x to the first power, which is an odd exponent, okay? But x to the 0 power is an even exponent. See how this is a mix of the two? That one's going to end up being neither. And I can show you that algebraically. If I plug in a negative y equals x plus 3, that doesn't match the original. If I say y equals negative x plus 3, or negative y equals negative x plus 3, that doesn't match the original either. So this one's going to end up being neither. One thing I probably should have included, but just to touch on it while I have some blank space in the video, something that's odd. So if I have y equals x cubed plus x, do you see how both of those exponents are odd exponents? And if I plug in negatives, negative y equals, if I cube a negative x, I end up with negative x cubed minus x. And then if I take all this and divide by negative 1, that would give me y equals x cubed plus x, which matches the original function that I was given. So that tells me that this function is an odd function. Okay. Again, key to kind of give you a hint on what we need to do. Odd functions have odd exponents for x values. Even functions have even exponents for x values. Hopefully that helps.